So thank you for introduction, Anasofi. So as Anasofi mentioned, that the overall strategy for the standards is to create a value. So hence the scope of this presentation is to provide how we can generate value in our business. And the overall direction of this presentation is towards problem. And we are looking for solutions. And me, along with my colleague, is supposed to be here, but he is in Germany. So we are working on this standard and how we can create a value out of this standard. So who we are, of course, Scania is a very big company, but who we are, why we are doing it, how do you want to do it, and what are the benefits. So who we are. Scania is a very big company. It has various life cycle stages. So here, they design products for the vehicle. There is a market, and they produce it here and deliver to the customer. So in a sense, customer will be more happy if they get a reliable products, right? And on time.
On time.
Yes, right. So within this production process, it goes to various stages, and we are interested in the make value, the production part. So in Sweden, of course, Scania has a lot of productions across the globe, majorly SLA and China. And within Sweden, there are almost 10 production units. So someone has to maintain it. Oops. Someone has to maintain it. So we are the company of Scania Industrial Maintenance. If you look into the overall production unit per se, it has two types of assets: the facilities that enables the production and the production machines. These are our assets. What is an asset? Asset is something that's create value to the business as per the ISO 55000 standard. Of course, these people are also our assets. Human. So it has 10 production across Sweden. Let's take an example of the overall the flow. So the truck consists of several systems, and some of the systems is a powertrain which drives the vehicle. An engine is one of the component or system. Depends on how you see it. So engine has lots of components, and let's take an example of piston. So in production unit, for example, one production machine produces a piston. Let's look at how it looks in the production environment. Let's take, there is a planned production time of 120 minutes. And let's take 40 minutes goes to the good production time. There will be a sum of defects, scrap. There's a slowness, efficiency, and downtime. So the machine is down. So out of all these produced pistons, only few of them are actually available for production, which is quite loss. Because if we produce less, the Scania produces less engines, it produces, and the customer will be disappointed because they could not get the right components at the right time. So the overall these three parameters are called OEE, overall equipment effectiveness. We are interested in availability, downtime. What is availability? Availability is like a duty cycle, the uptime, the total time. How much time the machine is available to produce. That's our responsibility. In a sense, like if it is available, this is the major hurdle for everyone. When a machine fails, nobody knows. It's difficult. So if it fails, we have to make sure that it needs to go up again. If you take a lot of time here, it will be a loss for the company. So the overall goal or objective of all the maintenance, not only Scania Industrial Maintenance, to reduce this downtime effectively, meaning the cost. You can do it faster with more cost, or you can delay it with less cost. Depends on context. So maintenance is responsible for the downtime part and also part of quality. So this is one of our major decisions. Okay, any component or system fails, When do we have to take action? Before failure or after failure? Which is the best? We don't know. Because each type of decision has its own complications or impact. If you want to do it earlier than estimated failure, then it's a loss of cost because you have to measure every time. It's a huge cost. But if you want to take action after the failure, again, it's a consequent cost because it takes a lot of time to figure out to make the system running up. So it's always a optimization problem about the availability and cost. This is our overall goal or objective. This is the problem we are facing. And in order to take this decision, like evaluate availability and also the cost, we need data. And we have to make sure that we need the right information to the right person at the right time. When I'm talking about the data, we have to make sure that we have get the right amount of data here on the. We need to have right amount of data efficiently so that we can take the decisions faster, so that we can have less downtime. So machine fails number of reasons. We cannot predict the machine fail. So what we have to do? What we have to do is, okay, let's take a CNC machine. We need to break down into functions into systems into subcomponents, and so on and so forth. So we need a system hierarchy where they exact the component of position. So we have to follow a problem solving approach. We cannot solve this big problem. It's impossible even. So we need to solve a part of the problem so that we can enable the decision faster. Let's take an example of what kind of decisions are usually for pump in this context. Okay, lots of decisions. So whether to have to take a decision before failure or after the failure. Before, either we have to repair it or do we have to replace it? Okay, if it is a replacement, shall we take from the same supplier, or it can be different supplier or a different model? Pump after the failure. Again, two types of decision. Shall we have to repair or replace? Replace, same supplier or different supplier? Same supplier or same model or best model? There are a lot of decisions to take based on the cost. And the overall goal is to reduce this downtime. So these are one of the major problems the maintenance field itself faces, not only us. So we need a data so that we can make this faster, quicker. What kind of data is available with us right now? That's a problem. We have data in different silos or different clouds. So there is one information which uses a Maximo. Of course, several companies uses a computer maintenance management system, which has asset information of the machine hierarchy that I shown, as not as simple as possible. Information about the failures. If you look into the quality of the failure information, you can't predict, you can't even detect it. The amount of maintenance plans, the cost and resources associated. This is also another important asset. It depends on how effective a person can make the maintenance action. So it's not only the technology, but also human, which is even makes complex. So we have a smart maintenance project that was built in-house. The idea is to get a condition monitoring data from the machine, the real-time status, and another complicated information about documentation. It spreads across various places. Something about machine manuals, maintenance manuals, electrical diagram, and the component manuals. These are all unstructured data. There is no standard. Surprisingly, there is one standard for electrical diagram, but there are different versions of standards. It is quite of semi-structured, and this little bit structured, not little bit. So our business case to, as I said, perform a root cause analysis to have a reduced downtime. But as you can see, the problems we face is that data stored in several sources. It is not structured. It is not integrated. It is not even verified. We need to validate it in order to implement, apply any model. So what are our impacts? We cannot able to perform root cause analysis, and knowledge is not being saved. Saved meaning that if something, a component fails in the future, we should know how it failed in the past. If we create that knowledge structure, then this knowledge is scalable. It's not. So the idea is to have an integration. So we need to integrate the data from the existing systems, sources, and also the documents. So what if we can able to solve the small part here? If you're able to solve this issue of issue about when a pump will fail, so accordingly make the decision. So it can improve the hydraulic system. It can improve the production machine. So it can produce lots of parts. It also leads to more engines. And the customer will be happy because Scania produce more number of trucks. So we are actually solving a part of the puzzle for the entire big problem in the overall life cycle management. So if you look into the overall dimensions, so our business case is this dimension, maintenance, and this is all the production side, and this is all the product side. So as Robert mentioned, we can use the URMSM model as an enabler to start this digitalization journey, because we need to data so that we can able to make decisions faster. So the overall, our since we are looking as a pump, because of our asset in this case, we use asset as a business dimension. We are responsible for it, and also the organization structure, because human is also involved. The production machine, production resource, and its automation, how efficient it can do the produce part, constituent parts. So if you look into the business dimension here, so here we are more interested in the asset part, because this asset creates our value to it, so that we can able to do our decisions better based on the how we structure the data, considering the resources. So it needs information about as semantics, as Robert mentioned. We need to define what is failure. Is it rupture is a failure, or the flow rate reduction is also a failure? We need to define the semantics. And information, structural information. Information is not enough. We have to get the data information technology, and communication across stakeholders. Same information should be available for both, for quality, for production, and for maintenance, because all three departments contribute to this production machine as an asset. On production dimension, as I said, we are responsible for also facility. So facility also impacts the production resource. If electricity is down, production cannot go anything. So facility is also part of the overall production environment. Yeah. So automation, how efficient you can do the action. And product itself, because we are talking only about a part of piston of engine, but it's a part of a big component of system within how you see it. So it's a composition of the function of the engine from the vehicle truck side. So this is how our data, what we call it looks like the overall scope. So we have the asset information. Asset information, the pump, it has a machine hierarchy, and various parameters are of interest. We have a maintenance plan for this component. We have the failure hierarchy, which is even more problematic, because we are taking over a type of component. If the pump type changes, this will also change. Model also change, everything will change. The condition monitoring data, the real-time data, like we are monitoring flow rate, pressure, temperature, vibration. Electrical diagram, which shows the position of the pump in the overall system hierarchy. And the component, the pump properties. What is the ratings from the supplier? This is our condition. It's in different clouds, not integrated. So this is for one production machine as an example. But in production environment, we have thousands of, 10,000s of machines. Like each one has this kind of a different structure, different component supplies in the same machine. It's a combination. But we are like 15 or 20 types of machine suppliers and hundreds types of component suppliers. So it's a big problem. So what if you have leverage this into a more data integrated approach? So that if you look at the lower stage, if you're able to monitor the condition of the pump better, so that we can assess the decision, should we take preventive action or a corrective action? Ability to detect, as I said, good or bad, enable root cause analysis, why this is happening, better assessment of conditions so that we can make a quicker decision making to reduce the downtime here, reduce the downtime at the component, reduce the downtime at the system level. More components, more products, and more vehicles, and customers will be very happy. So hence, when we looked into the overall working with this group, we understood that this model enables us to start our digitalization journey to enable considering the holistic perspective of the maintenance function, which is more multidisciplinary approach and complex. We think that if you're able to develop a simple one version, then it can be scalable across various types of methods, because we are not following a typical standard. We try to use various domains, because pump, it's both mechanical, but if you connect it to IT, it's again electrical. Okay. So it's a two domains interacting together, accommodate existing standards. And this is what even more interesting for us, modular approach. As I've shown you as an example here, if you're able to just replace one component with another component, it can able to, because use a similar kind of information models. And this also enable for utilization of AI and machine learning, because we need to understand the data first to apply before that. If you could be able to understand, it's a garbage in, garbage out. So it's a prerequisite for our digital twin, the basis for our entire digital twin, so that we can make a better decisions and create a value to our business. Final thoughts? How many of you seen this comic? Which I like it more. Try to make a different standard. We use our terms from the standardized terminologies, as Ulf mentioned. Thank you.